Good day, Kabibal, and welcome to our Facebook Live session. For today's discussion, our topic will be on Precalculus and Basic Calculus, gist and ideas on DepEd's MELCs. Before we begin, take note of the following reminders. First, make sure you are registered to the webinar to have your e-certificate of participation. Visit certificate.vibalgroup.com to generate your proof of attendance. Place your questions on the comment box allotted during the session and they will be addressed by our speaker later on. Share the video using hashtag LearnAsOnePH as our official hashtag to our Bibal webinars. Experience learning, Kabibal. And now, to proceed with our webinar this morning, it is my pleasure to introduce to you our distinguished speaker for today. Our speaker for today is an editor of Vibal Math Books. He is also a close friend and an avid supporter of DepEd. He is an associate professor of Department of Mathematics of Ateneo de Manila University. Ladies and gentlemen, please welcome Dr. Ian June Garces.
Hi. Hi, good morning. Good afternoon ba o good morning? Tulog pa ako. So I thought that my work in K to 12 has ended long time ago, but we are here back again about K to 12. We have a challenge in front of us, and we need to address. So this time, I will be going to discuss in continuation with the discussion last Wednesday. If you're around, you were Miss Bernadette Daran of DepEd Bureau of Curriculum Development discussed the grades K to 10. So what I'm going to present to you will be part of the senior high school, and it will be on pre-calculus and basic calculus. Allow me to share with you my screen now. I hope you can see it. Does everybody see it? I hope. Michelle, can you see it?
Yes po, Doc.
Okay, thank you. So my role today is not really to enumerate to you the DepEd's most essential LCs, but we're just going to look at the gist about them, and I will also inject some ideas about the DepEd's MELCs. So first, I will talk about the original plan. By the way, before I forget, thank you, Vibal, again for this opportunity. Sorry to forget that one. I'm also grateful to DepEd that until now they still trust me. It has been a while. I am with DepEd. I'm supporting DepEd and doing some technical stuff since the birth of K to 12. So I think in terms of the subject area in mathematics in K to 12, I have been since the time it started. So from the planning to the crafting of the curriculum to the writing of materials up to training of teachers and the trainers, Then until now, the revision. In fact, during the time of Brother Armin, I said to him, Brother, pagkatapos nito, tapos na ako. Sabi niya, hindi meron pang mga raming reviews now, nandito na nga. Okay, now this is different. This is different because we have a challenge in front of us this time, and we need to somehow um, adjust our curriculum. Adjust our curriculum. So let me go again back to the slides. The original plan for both pre-calculus and basic calculus are this. Pre-calculus is actually a course created to complete the basic math needed for calculus and for future mathematics courses. That's the reason why there are more topics in pre-calculus that are more than what we need for calculus. It's not more than what we need for basic calculus in grade 12, because it's not really pre-calculus there. Pre-calculus in the original plan is not really only for the basic calculus in senior high school. It will also cater the future math courses. So it will actually it's actually the course that will be needed for those going to the STEM courses. Now, remember the original plan for K to 12 and the university. There will be no pre-calculus anymore in the university. That was the original plan. That's the reason why pre-calculus will not only cater the basic calculus that we know for senior high school, but will actually complete everything, so that there will be no pre-calculus in the university. Because as what was planned before, the first math course for for STEM courses in the university will be calculus. So pre-calculus is very much needed in there. Now, the goal of basic calculus, the original goal of basic calculus, this is a basic treatment of calculus to support the senior high school sciences. For example, physics, they plan to have a calculus-based physics, so that the engineering courses in the university will be finished in 4 years. And it is identified that calculus is the problem if they're not going to take basic calculus in senior high school. So that's the reason why basic calculus was created, so that the engineering courses will be lessened. Okay, that's the original plan. Now, in fact, this was the two courses were actually finalized in 2013. Okay, I was one of them in the picture. Okay. So it was in Laguna. It was finalized in Laguna. Now, this time has changed. There is a pandemic that we are facing, and to be honest with you, in our school now, we are having intersession. That's the summer class that's usually done in other schools. We have intersession. We call it intersession, and it's online. It's online, and in my own experience, we cannot really finish. We cannot really finish the original plan. Meaning, for example, the original syllabus of the course, it cannot be done. It cannot be done because it's just that there are so many factors. So, but we cannot stop learning, because we need as they say, schools may be closed, but learning is open. So we adapt. Now, DepEd recently produced, they call it the most essential learning competencies. We will describe them in a while. So this is really This is really to address or to adopt the new thing that we have, the new thing that we have now. It is not the case that it is not the case that pre-calculus, the topics there are not essential. No, they are essential because of the original plan that I explained. But you see, you need to lessen the number. It's just that it will not work. It will not work. So during the final stage of the curriculum, uh, Miss Bernadette Daran of BCD again sent me this almost final copy of pre-calculus and basic calculus curriculum, the MELCs. So I was able to see and to see what will be she wanted me to comment on the curriculum. Then I was trying to explain that this part is really needed for this and so on, because you're not going just to this, you're not just going to look at pre-calculus. If you look at pre-calculus, you have to look at basic calculus as well, because this is some sort of a tandem. So I saw that the competencies, some of them were dropped, some of them were merged, some of them were transferred. Okay, but these are as what I see it, this is just something like, for the meantime, we have this on. But after this pandemic, we have to go back. We have to go back to the original pre-calculus or the basic calculus. Then, if not, then we will have a problem. The students will really have difficulty when they enter the university. Now, true that really this if you're going to go through the MELCs now, the students will really somehow find new topics in the university a bit difficult. That is true. Okay, we cannot really impose, or we cannot really follow the same curriculum. But we need to go back after this pandemic. We really need to go back after this pandemic. Now, in their guidelines, essential learning competencies were defined. These are essential. Meaning they cannot be ignored. They are needed for the foundational skills. But it turns out that there are many, because as I see it, they're all essential. But we need to discard many, okay? Because we cannot finish the curriculum. So they considered now the endurance condition. So the endurance condition is actually a competency is considered to be enduring if they need to be remembered after a test, or after the course, but still the topics that are not included now in MELCs are really important. So what I will do now is just to go through with the pre-calculus curriculum content topics. In the original curriculum, we have the first batch, we will have the conic sections and the systems of nonlinear equations. You may not say, for example, you may not agree that systems should be there because we don't need systems in basic calculus. True. That is correct. We don't need systems of equations in basic calculus in senior high. But when the student reaches the university, when they take calculus, they need systems of linear equations, nonlinear equations. So that's the reason why in the original curriculum, there is systems. Remember, the original plan was not just for basic calculus, but also for the future mathematics courses. That's why we have there. But in MELCs now, the systems of linear, nonlinear equations are dropped. Okay, so for the meantime, then the next batch of topics is the series, mathematical induction, and the binomial theorem. Remember, the binomial theorem, if you're going to consider, if you're going to prove the derivative of x to the n is nx to the n minus 1, you need the binomial theorem. However, as you will see in basic calculus later, there will be no derivation anymore. So binomial theorem here and mathematical induction are dropped. We now have series only. Now we cannot afford to discard series because later you cannot, basic calculus cannot explain integral as a form of an area without the knowledge of what we call Riemann sums. And series in here will not just go back to geometric arithmetic. No, what is important in series in here now is the summation notation. So the next batch will be the trigonometry. So we have the circular functions, trigonometric identities, inverse trig functions, and the polar coordinate system. Now we drop the polar coordinate system. Then you might say there are still many because there are so many trigonometric identities. No, there are learning competencies now that are also dropped. So by topic, trigonometric identities are there, but some of the competencies are dropped as well, or merged, or transferred, and so on. Now, for basic calculus, the same. We have the limit and continuity. We still have the limit continuity in MELCs. We have the basic differentiation. We also have the basic differentiation, basic integration, and basic integration in MELCs. However, you may say nothing is changed. No, some competencies are merged, transferred, and dropped as well. So we may have the limit and continuity. We may have the basic differentiation. We may have the basic integration. However, some of the competencies are dropped. So MELCs now will have fewer learning competencies. Now let's look at the gist. On the, I will not, as what I said right at the start, I will not be enumerating all the competencies. You can refer that one to MELCs. I know you have a copy of it now, a copy of the MELCs, the curriculum guide for MELCs. I will just look at the summary or the gist of this thing, the gist of the topics. Now, quarter one, which is, remember, pre-calculus and basic calculus will just be about 1 semester each. So there will be 2 quarters each, 2 quarters each. So the first one will just be to illustrate the different conic sections. Okay, so instead of well, you can draw the conic sections. Okay, of course, in here, if you say illustrate, you also have to define and so on, to define what it is, what it looks like, and so on. Here, I lumped up all the standard equation of non-degenerate conic sections. It means in here that because the conic section, the number of weeks is the number of weeks devoted for this one is 5, then each week you actually have 1 conic section. Okay, so you go through with the conic section per week. You define, you illustrate, and so on. Then you look at the standard equation. As much as possible, we do not look at anymore the general equation because the reason for this, anyway, ang ending naman nun, standard equation lang dapat ng conic section para ma-identify nila. So here, you need to identify the conic section from the equation point of view. you also have to identify the equation. So back and forth, meaning from the graph, you can identify the equation. From the equation, you can identify the graph. Okay, yun lang yung point doon. Of course, you need to define the basic uh, terminologies of conic sections. Now, in terms of online, this is very quick because there are online softwares that are free that we can actually share to the students. Now it's really a challenging it's really a challenge for DepEd really to cater all types of learning. May it be blended, may it be something like online that we use technology and we use this. But I suggest that instead of having DepEd has so many challenges in front of them. Instead of having some challenges, I think we can do something on our end. Then the next batch will be the series. This will be quarter 1. And if you look at it, the quarter 1, instead of 10 weeks before, we now have 9 weeks. So every quarter now will have 9 weeks. And 9 weeks with less competencies. Now, next will be the series. Of course, we differentiate series from sequence. Okay, so that because we understand that we will have a series later, and take note, in grade 10, they already have sequences and series. So for now, we just have series and from sequence. Then we introduce a sigma notation. The sigma notation is quite important because we will need the notation in calculus. Now, I'll share something with you to look at this one here. There is an app which is a free app, and I'll share something with you. Can you see this, Mitch? And so, can you see the new slide?
Yes po, Doc.
Okay, thank you. Now, I want to, this is autograph. For those teaching pre-calculus and basic calculus, this is autograph. And before it's a paid software. Now it's free, totally free. So here, let's introduce. I use this. By the way, I'm teaching pre-calculus this intersession in our school. So let's look at how autograph can teach us conic sections. So I'll enter an equation. This is actually the 3-dimension. Okay. R equals Z. Let's talk about the polar. Okay, cylindrical to polar. Do you remember that if you are a teacher in pre-calculus, this is sometimes we cannot draw this one. We refer this to videos in the internet, but now there's a software that we can actually use. Okay, we can actually use. And the nice thing is that we can flip this one in here. All right, so that's the idea. Now, we know as a teacher in pre-calculus, we know that the conic sections, they are called conic sections because they're actually section of a conic. Okay, para bang, ano ba yun? Ano yung conic section? Section ng conic. Okay, para ba yun? Okay, anyway, ito yun. Let's look at another equation, and I think you can now identify that let's say Z is equal to A plus BX. Then you have a plane. Okay, you have a plane. Let's make B equals 0 and A equals 2. Now, to show your students that actually a conic section is the intersection between a plane and a cone. This is a circle. That is the circle that we are referring to, this part here. Okay, so this will show to your students that it's a conic section, and all the conic sections, the degenerate and the non-degenerate conic sections, can be found here. Now, you notice that, sir, this is a circle. How can we create the ellipse? Well, if you can create the ellipse by actually increasing the b. Then if you flip in here, this will now be the ellipse that you see. This is now the ellipse. Okay. If you continue clicking that one, if you continue increasing the b in the z is equal to a plus bx, then you will create this parabola here. This is the parabola that we are looking at. If we say, this is the parabola. This trace in here is the parabola. As long as it will not intersect the other cone, it's a parabola. Now, if you continue increasing the b, this plane will tilt more, and this plane in here, this plane will now intersect the other nap of the cone, So if we continue doing that, it will now be intersecting the other cone. Okay. Now, teachers in pre-calculus or teachers in math, we know that this is actually the hyperbola. Okay. So the graph that is traced by this one is actually the hyperbola. You see now in here, you will see really the asymptotes. You can visualize the asymptotes of the hyperbola. Okay. So now this is one way. This is one way that this is nice thing about online, because we can now use technology. Okay. I will not discuss, because it's really for me too. I find it really challenging. How about those without this stuff? Hindi ko siya kaya sagutin. Mahirap talaga siya. Hindi mo talaga maibalik yung kagaya ng ginagawa natin sa face-to-face. So meron talaga tayong masacrifice. Okay. Now, I'll go back to what I shared a while ago. Now, as I told you, I am actually currently teaching pre-calculus in our school. I gave this as one of the items. One way really is one of the things that really, well, we have to think about will be assessment. Because sabi nila, paano yung cheating and so on. If a student really wants to cheat, he can cheat, even in on-site classrooms. So, di mo bang, kung gusto talaga, magawa talaga niya, even dun sa klase pa natin. But we are trying our best to minimize possibility. Now, take note that there are graphing utilities now. For example, that autograph can graph. But there are questions that will actually allow them to think. For example, I ask one. Our exam, by the way, our quiz, by the way, is online. So instead of asking them to graph, I graph it myself and ask them. I posted this one in our FB group. Instead of asking them to graph, I ask them to identify the equation. That's different now. Okay, that's different now. Because I'm not sure if they can still have something that they will put in there, and they will put in the app that will give us the equation. So this is something that you can think about. We may not be able to eliminate, but somehow minimize the possibility. So I ask them, find the equation of this hyperbola. Okay, so that's one way. So I put them there. Now, trigonometry as well. In pre-calculus, trigonometry is, you cannot avoid trigonometry in pre-calculus. It's really important. The first will be to introduce them to, of course, here we need to convert degree to radian. But of course, you have to introduce what degree, what radian measure r. For example, they have to define the linear or the angular measure and so on. So although it says in here convert, but there is a competency there that you need to illustrate how do we get degree and how do we get radian. The next batch will be the circular functions. Here, take note that the approach that we use, although we say that trigonometric functions and circular functions are the same. Yes, true. That means they are just approaches. In the trigonometric functions, the approach is via geometry, the triangles. Okay, but you will lead to the same 6 trigonometric functions. You still have sine, cosine, and so on. However, the circular functions, the treatment will be on circles. So the approach is on circles. That's the reason why we need to have radian measure. We need to have radian measure because the approach that is suggested in precalculus is circular. So that you can actually think of the real number system, the set of real numbers as the domain. Okay, so so circular functions and trigonometric functions are the same. The approaches are different. On the circular, we approach in the circle side. On the trigonometric, as a trigonometric function, we approach on triangles. Okay. Then of course we need to have to graph the circular function so that they will be familiar in graphing. This will be the usual aids, like for example the amplitude, the period, the phase shift, and so on. So these are the 3 common aids in graphing trigonometric functions or circular functions. Now here, look at this. We are now shifting to trigonometric functions, the common ones. Okay, so we now have to apply trigonometric identities to find trigonometric values. So we will not anymore be deriving or proving trigonometric identities. We just apply them in finding the trigonometric values. Now, this is important, especially in physics, wherein you will get some angle in here, there will be an additional angle the next, then and so on. Now, we cannot discuss trigonometric equations without inverse trigonometric functions. Okay, so we can only solve trigonometric equations if we know inverse trig functions. Okay, and along the way, we also discuss what inverse function is, how do we get the domain, and so on. Now, of course, we need to solve. There are a lot of problems here. Now, I want to share again back the autograph. Because in autograph, you actually have some extra thing. And this will really amaze you. Okay, now look at this. This is trigonometry in autograph. Now, we can actually sketch the graph of sine, cosine, and tangent at the same time. So this is now, the approach in here is circular because the values of the sine, cosine, and tangent. Actually here you can see that this will be the sine, this will be the cosine, this part is the cosine, this part is the tangent. Now, if you click this one in here, it will actually draw and it will actually trace the circle in here. This is the circular approach of trigonometry, of circular functions we call. These are the graphs of sine. So this is the sine function. This will be the cosine function. This will be the tangent function. And you can check in here which of the 6 trigonometric functions you like to sketch. So it can go back as well if you like. And it will go back here. Or you can go forward as well. If you go forward, and it will go forward as well. And so on. Okay, you can check if it's degree, so that will be in the radians now. You're now in the radian measure and so on. So there are ways to, instead of graphing the trigonometric functions manually, there are actually things that we can do. So I'll go back to that. Okay. Let's look at the gist of the basic calculus MELCs. Now, this is crucial because precalculus, maybe it can be used in physics for the trigonometry. We can all the precalculus is catering calculus as well. Basic calculus is really catering physics. So crucial in the sense that basic physics may use topics in basic calculus that are way in the middle. The problem is math cannot discuss those things in the middle topics. Like, for example, they wanted derivative. For example, they want derivative because the derivative of a distance function is the velocity or the speed. Then after that, differentiating the speed or the rate, the velocity, you'll have acceleration. But you cannot teach derivatives without passing through limits. Now, if you want work, for example, work will just be discussed in somehow in integral from this to this one. But you cannot discuss in integration without differentiation. So they need topics that are quite at the end or middle of calculus. But we cannot discuss calculus without basic topics. All right? So that's the reason why we have to go through with limits. So again, you will introduce limits. Technology can introduce that one, what we mean by limit, what we mean by continuity. We look at the limit laws using polynomial, rational, and radical functions. We extend using tables now. We don't compute, we don't derive. Using tables, we are going to look at the limits of exponential, logarithmic, and trigonometric functions. And remember, we need the derivative, for example, of sine. We need some special limits because you have to describe what derivative is. For example, in the next batch of topics, we need, hindi mo lang pwede sabihin lang, derivative ng sine ay cosine. Hindi pwede mo sabihin yon. Kailangan mo pa rin yon ipaliwanag at somehow, saan nang galing yon. Alright? The limit of x squared is 2x. Kailangan mo mapaliwanag ng konti yon. So therefore, we need some special limits. We need some special limits using tables. Then we can go to continuity of a function. So continuity is needed because there are problems later, especially if you have maxima, minima. You need continuity. You need the idea of when a maximum, minimum values occur. So we need continuity. This may not be needed, but the problem is somehow basic math should have at least, kumbaga meron siyang content din na buo. Hindi pwede lang na, okay, hindi na kailangan, hindi na natin pag-usapan yon. Parang ang dating noon, parang ang kawawa naman yung basic calculus na ituro mo na, kaya lang hindi naman kumpleto. So somehow, we still stick to the idea that basic calculus is still a course. It must have, hindi pwede yung, parang ang dating ba na pinakain ka, pero hindi ka pinainom ng tubig sa pagkatapos. So mahirap yun. Kailangan mong uminom naman ng tubig. So that's the reason why, although we were able to cater the topics needed for other courses like physics and so on, kailangan din nating makumpleto konti yung basic calculus. That's the idea. Basic differentiation, of course, we now have to relate the two. Anong pagkapareho ng derivative at slope? This time, you need that definition of the derivative. Remember that limit as h approaches 0 of f at x plus h minus f of x all over h. The derivative, you need to connect that one with slope of the tangent line. And of course, we need to look at the differentiability and continuity para mo magamit mamaya sa extreme value theorem. We will look at that one in a while. um, we will look at, you have to, but we never now, we do not derive the differentiation rules. Okay, we do not derive the differentiation rules. Then we extend until transcendental functions. Transcendental functions are expo, log, trigonometry, and inverse trigonometric functions. This is extreme value theorem, was supposedly in the later part of derivatives, but it was transferred here. It is transferred here because you cannot discuss maxima, minima problems without extreme value theorem. In here, we want polynomial optimization will only be for polynomial functions. Yung problems that will result to polynomial functions. So that continuous siya, because it's continuous, then it has maximum values, it has minimum values according to the extreme value theorem. That's why we need continuity and extreme value theorem. Then the one last exposure to the basic calculus will be the related rates. We cannot discuss related rates without implicit differentiation. That's implicit differentiation. We cannot discuss implicit differentiation without chain rule. That's why you'll have chain rule, implicit, related rates. Okay, so we go back, let's move on to basic integration. We need integrals because we want them to find area so that they can use that in work, in finding work in physics, they use area. So of course, the usual, let's introduce what we mean by antiderivative. What do we mean by, how do we use antiderivative? How to write integral using substitution rule. Now, here is the thing. We need, after that one, we need to apply using the exponential growth and decay. This is important because although exponential growth and decay was perhaps discussed in Gen Math, in expo log, yes, but anti-differentiation will explain more. It can explain more. Why is it that exponential growth and decay, e to a PE to the KT, bakit yon ang kanyang equation? Ganyan ang kanyang formula. Anti-differentiation can say more, That's why it's exponential growth and decay. Now, here is the idea, Riemann sums. Once from antiderivative, we want to connect it to definite integral, meaning from integral of f of x dx only, we need to connect that to integral of f of x dx from a to b. That's the definite integral. But the connection there is via Riemann sums. That's the idea. So Riemann sums need the sigma notation. So that's why we have sigma notation, and we can compute the area, we can compute the total areas, and so on. Then we have the fundamental theorem of calculus, because that will be the computational formula for definite integral. And of course, we use substitution. And finally, we solve areas. Kumbaga, ang kailangan ng physics is solving areas of plane regions. Pero nasa dulo na siya. We cannot get that into that level if we don't have the basic integration. I'll show you another way. I hope you can use this. Again, I'll share something. I hope I'm still okay, Mitch, with my time.
Yes po, Doc. Okay pa po.
Okay, that's good. I want to end quickly so that I can somehow answer some of the questions. I know I cannot see you. I cannot see your comments. Mitch, meron na ba? Marami na.
Yes po, Doc. We have some questions na po for later.
Nakakatawa ito. Patay talaga ako dito. Just, wag mahirap ha. Math na lang itanong nyo. X plus 1 equals 0 na lang. Pwede ba yun? Okay. Let's try to look at what autograph can do in Riemann sum. Here. Okay. So let's try. Let's try to have y is equal to x squared plus 1. Yes, that's the graph. of y is equal to x squared plus 1. And allow me to choose these 2 points here. And allow me, yes, that's 0 and 2. Let's compute the area. Let's compute the area below the area under this curve below the y is equal to x squared plus 1. And we compute that basically using the integral. But you cannot go directly to integral without explaining why it is an integral. This is what I meant when I said you cannot go directly to fundamental theorem of calculus without passing through Riemann sums. So I'll choose this. Then I'll compute the area. Now let's compute the area via the lower rectangles. So you see in here that this will be the underestimation of the area. In calculus, we want to make this number of rectangles go to infinity. You see the area here is actually 3.92. I'll double click that one. So you can see in here that the total area of these rectangles, 5 rectangles, because we created 5 rectangles, the total area is 3.92. Now, what we want in calculus is that to make this one more rectangles. Then you see, it will increase the number. So if you increase the number of rectangles from here, it's 5, we increase it to 6, you will notice now that the area now changes. Now more rectangles, it will now actually approximate down below. So more rectangles we have, we can approximate the area. Okay, now of course you can also approach this via the one above. Okay, via one above. You can create for a while. I'll delete this part here. Create for a while. I'll delete this part. Yes. Then you can approach this via the left, the overestimation. The overestimation. And that will be create area. Let's look at rectangles right. Then you will be overestimating. You'll be overestimating. And in fact, the total area there, the total area is actually 5.52. Now, just like what we did a while ago, we can increase the number of rectangles, and you will see in here that actually those rectangles that we created a while ago and the rectangles that we create now, their total area will actually meet somewhere in between. And we say that that is actually the approximation. And as you take the limit of the Riemann sums, as the number of rectangles increase, then it will then be the integral from a to b of f of x dx. So this is one way to approach. This is one way to approach integral, because this is using technology. Without technology, by the way, in class, if you do it manually, we'll just say to the students, if you increase the number of rectangles, then you will actually approach this value. Here you can do the technology if you like. So I'll go back to that one. I'll go back to this. Share. So that's it for now. That's it for the entire discussion. Allow me to invite you. Some of you might not be members, and for those who are here, those who are watching, who are members of Sipnayan 360 degrees, I am Ian Factorian. Okay, there. Okay. It's an active math group. It's an in FB. You just have to uh, apply. You just have to apply. So I'm inviting you if you're not yet member. So stay safe and well.
Okay, thank
Thank
you po,
you.
Doc Ian.
I'll stop sharing.
Okay po. Ayan po. So we will proceed po now with the question and answer portion. Okay, let me read the question po. First question po from Mr. Romualdo Quesada. Can we discourage pen and paper tests in math subjects, both for modular and online classes? Thank you, and I hope you can answer my question.
No, there are times we're in. There are times we're in. I will answer that one based on my experience on online. We have online classes. Ano yun, Mitch?
Modular po.
Online and modular. No, there are hindi naman discouraged, not discouraged. Sometimes in math we need them uh, uh, to write, and to explain or to draw to see the solutions. If there's no other way, if your LMS, for example, your learning management system, will allow them to write, then that will be good. But if not, then why not pen and paper? You just allow them to send it to you. Okay. So we use that here in our school. We are using online, pure online, and our LMS, our learning management system, can allow a submission by using pen. They solve, they take a picture, and they send it to us. So it's not really discouraged, because this is the one of the peculiar things in math. We need really solutions, and solutions for students may find it difficult if they write. Kumbaga parang ano lang, parang text editor lang, mahirap. We need to write because sometimes our symbols may be difficult. So yes, pwede naman siyang ipapasubmit and you check. Pero wag naman palaging ganon, kasi pa, parang ang dating kasi nawala yung essence ng online. We somehow look at online. Me, in my case, I allow them to uh, have multiple choice. We have true or false, and we also allow them to have in our LMS. You can have questions that will guide them. For example, through the steps. So you must reach this part in here. For example, I ask questions on circles. I will ask them, what's the center? Then they will input that one. What is the radius? They will input the radius. What would be the center radius form? Then they will put the center radius form of the equation. Yung guided na questions in one question. So somehow you are going through with the solution itself. So pwede yung ganon. Pwede yung ganon. Pero wag naman, halimbawa, if you really want to see if the students are able to, kasi meron tayong skill na kinukuha. Alam ba niya tong skill na ito? Pwede mong pasulat na naman ng papel kung hindi kaya doon sa LMS. Yes. Thank you.
Thank you po, Doc. Next question po from Miss Francesca Lim. Any techniques on how we can teach solving of trigonometric functions manually in order to ensure that students understand them on their own rather than depend on the capabilities offered by the applications?
Yes, there are. Kasi as long as yung technology, for example, I used autograph here. I used autograph. Hindi naman hanggang doon lang. Dapat mapaliwanag pa rin ng bata bakit ganun ang nangyari. Hindi yung tipong when we draw the trig function, the graphs of trig functions, we're not going to end by just graphing. You need the student or you can explain why is it that the graph of sine is this. So the the technology that I use, the one with autograph, the one with graphing, it's not there just to show that this is the graph, then that's it. Students must also explain. So for example, they may be able to find the sign of, let's say, pi over 6 is 1/2. You can ask them if you can explain that, why is it 1/2? So technology is just a tool. Pero hindi na magdepende doon na learning is both ways. With the help of technology to make things better looking, or something like, if you want a 30 degrees, it's really 30 degrees. And writing, or meaning manual computation, will really help them understand. But technology can make them visualize. It's different when they solve and they have a picture in mind what's going on. So visualization is important in math. For example, when you are going to discuss, let's say, trigonometric values, you said exact trigonometric values. At least makita na ng bata, ganito yun, ganito yung ibig sabihin nun. So technology is there just for the sake of visualization. But of course, understanding is important, and you can allow them to compute for you. Sige nga, mapaliwanag mo ba or makompute mo ba ang gamit ng dun sa nakita mo sa technology. Dapat ganun din. I will not end on technology, but I will ask my students to parang tibo ba, why is it that it is this way? Okay. So, thank you.
Thank you po, Doc Ian. Next po, question from Miss Al Cameron Avila. Will it not affect the acquisition of concept by students due to introduction of MELCs? Thank you po.
Will it not affect the acquisition of concepts by students due to introduction? And somehow it does. It does. Kaya lang we cannot. There are concepts really. For example, I hope I understand you correctly. The MELCs are parang ano siya parang reduced form ng original curriculum. The original curriculum is still the complete one. Somehow we if you reduce something, you will sacrifice something. So yes, it does. There are concepts. For example, you want to create this idea of how to logically conclude that this is the sine square this sine 2x is equal really to 2 sine x cos sine x, for example, in precalculus. Because you cannot derive them because there's no time for derivation. That concept of logical thinking may be in logical thinking in the sense of deriving a formula. Yun yung mawawala. Yes, true yun. Kaya din, pero it's just the way it is. Hindi mo pwede isaksak lahat ng original na curriculum without sacrificing something. Na isaksak mo lahat ngayon para sa this time of crisis, for example, hindi mo kaya. So we really need to select. True.
Thank you po,
There
Doc.
is. Okay, thank you.
Next po is from Miss Hannah Louise Grescia. Sir, any tips on how we can teach finding derivatives and other functions in a more digestible manner in order to ensure that students fully comprehend the process involved and to avoid reliance on calculators and other devices?
Yes. There is their illustration. Again. There is this conflict. I'm not sure if it's conflict or what, from old school from old school. Me, I belong to the old school. Uh, I still choose to teach. I still choose to teach in chalk and blackboard in Ateneo. I do not use technology. I do not use those uh, ano ba yon, yung mga presentation. I hindi ko siya kinagamit. I still use chalk and eraser. Um, but I understand that there will be students who will rely much on calculators and devices. But you see, if you can train them, to discipline themselves, and you can ask from time to time why the calculator, these devices produce these values, then that will be good. Okay, so that they will be checked. So there are ways to check. Not on relying on calculators and so on. For example, you can allow them to compute derivatives via the three-step rule. Yung mga ganon, yung f of x plus h and so on. Okay. Now, on solving derivatives, in my case, I always look at introducing derivative. I always challenge the students, the minds of the students. I always start, because you see, derivatives will be maybe slopes. These are slope. Derivative comes from the slope of tangent line, and the slope comes from the slope of lines, right? Notice that you can also connect this one using speed, because if you have the distance function and you take distance function f, for example, f of t plus h minus f of t all over h is actually speed. So you can approach in both ways. In my case, I approach in both ways. For example, I approach using, I will look at a graph, and I will connect them what they know in geometry. Geometry says 2 points determine a line. Okay, so I'll draw the line. Then after that, I will ask them, what if you want the equation of the tangent line, the point wherein it's just tangent to this? You cannot use geometry because there's only one point given. Then how do we approach that? How do we solve that? It cannot be solved by geometry. Then here's derivative that we say. I always approach it that way. So I challenge the student's mind, o nga no, paano kung isang point na lang? And you see, if you will allow your students to draw the tangent line to a curve, they can graph it. They can graph the tangent line. So if you just say, this is tangent, because their point of view is coming from the tangent to a circle, point of tangent to a circle. And basically, if you have only one point, you cannot find the equation of the line because there's only one point. Then that's slope. Then we need, okay, you consider these 2 points in here, then you slide 1 point until this one. We keep on having 2 points until the limiting line will be the tangent line, and that will be the derivative. And you also challenge on the other hand, that suppose this is the car, after some time, it will reach this portion. This will be the distance function. Now, you will ask again, if you compute the speed, you need the car to travel, because that will be the time, the distance, the last distance minus the previous distance all over the time. That's the speed. But what do you want is, what if, for example, in your car, in the cars, you will see speedometer there. Paano niya na-compute yung speed? And that will be the speed at that instance. Now, if you compute distance function t plus h minus f of t all over h, you will notice that, the students will just say, yung speed pala is the same as the slope of the tangent line. And they will be amazed with that one, because you only have one kind of expression. We call it the difference quotient, but they represent different ways. It depends on what the function is. And they will see, ang instantaneous velocity pala at this point will just be the limit, and that limit will just be the derivative. and the derivative will simply also be the slope of the tangent line. So you are looking at two different ideas, but the same concept. That's what makes math beautiful. You have one concept, it actually applies to many ideas. That's it. Thank you.
Thank you po, Doc Ian. Last question po from Mr. Marlon D. Golong. Do you agree that STEM students should take and finish the pre-cal and basic calculus subjects first before having physics in senior high school? Because physics subject is taken in the same year as calculus subjects po.
Okay. My take on that, I will go back to the original plan. To the original plan. The original plan was, I'm not sure now what is happening in the current scheduling. The original plan is um, in senior high school, there are actually, for STEM students, there are actually 4 math courses. The Gen Math, then the Statistics and Probability, then Pre-Calculus and Basic Calculus. Correct. So these are the 4 for STEM math students. Originally, we agreed with sciences. We agreed with sciences when it was created in 2013, original 2014. We agreed that uh, pre-calculus and basic calculus should be in grade 11, and physics should be in grade 12. That is the main reason why there is no math in grade 12, because they are now used. That's the reason as well why those research subjects that need statistics are in the grade 12, because we need to finish statistics and probability by grade 11. So it depends. It's really difficult. It's really difficult without basic calculus. If you teach really physics, the calculus-based physics, the way it was planned, na kailangan sa grade 12 siya, at saka calculus-based. Kung hindi naman siya calculus-based, then walang problema. Pero I'm sure the reason why we have basic calculus in senior high is because physics wants calculus-based physics, so that in the university for engineering students, ang kanilang pasok sa physics will be calculus-based already. So para hindi na mahirapan, hindi na magkakaroon ng 5 years. Now, the same way, nalala nyo yung in the past, that was changed actually in K to 10. In the past, physics course, the physics in fourth year, when it was fourth year, physics in fourth year introduced trigonometric functions right at the first or second quarter, wherein in the math curriculum, trigonometry is discussed in the last quarter of fourth year. It was changed. It was changed in K to 10. Now, that's the reason why trigonometry is in grade 9, last quarter, so that physics can freely now discuss trigonometry in grade 10. In grade 10. It's not nice to para bang hilaw yung pagkaturo ng I'm not saying that mali ang tinuro ng physics, pero ang sinasabi ko na tipo bang hilaw yung pagkaturo kasi they only teach what they need. Now you will be teaching what's supposed to be learned. And the thing is, if you're going to teach what you need, as what was asked before, may mga concepts na posible na magkamali, na ma-misinterpret ng bata, mahirapan ka na mag-correct nun sa iyong side kung pagdating mo naman sa subject matter mo na. So kailangan mauna sana tayo. So in this case, in your question, I hope that because in the original plan, physics is in grade 12, and basic calculus should be in the second semester of grade 11. And pre-calculus in the first semester. That's the original plan. That's the original plan. I'm not sure now what's happening. Thank you.
Thank you po, Doc Ian, for answering the question of our Kawibal viewers. For now po, any last reminders to our viewers today, sir?
Yeah, yeah. Um, Somehow this year or this school year, or maybe we do not know, is really different from the previous school years that we have. We need to adjust. I understand that we know that we have reduced the learning competencies. We cannot really experience-wise, we have experience here in this intersession in Ateneo. It's really different. It's really different. And I know, I understand that it will be difficult for teachers. Now, it will also be difficult for the learners. Both sides, both sides. We have to be compassionate, not in the sense compassionate na wala na lang ang gagawin yung bata, tuloy-tuloy lang. Wala. Hindi naman ganon. We understand. I mean, we understand. And um, we do something before we complain. If we keep on complaining, we keep on reacting, baka nakalimutan na natin yung formation natin, yung how we are formed and how we are designed. Baka kasi nawala na tuloy yung kagandahan ng education dahil puro na tayo reklamo. We do something first. We do something on our own. We adjust. This is different. Yes, this is difficult. Wala namang hindi nahihirapan. So, I hope we will have you will have a better experience. I experienced it already. I hope you will have you have experienced it as well, or you will experience it beautifully once you are called for during the school year. Sana okay tayo. Sana at saka sana makalagpas na tayo nito para makabalik na tayo sa dati. Sa dati. Okay. Thank you.
Okay, there we have it. So, in behalf of Vibal Group Incorporated, I would like to thank you, Doc Ian Garces, for this very insightful learning session we had today. It is an honor to have you with us today. And of course, to all our Kabibal viewers, all thanks to you for your continuous patronage to our daily learning session. Muli maraming salamat at magandang araw sa ating lahat. See you po again. Bye!